So today we are going to be working on applications dealing with right triangle trig. So the first two terms we're going to learn is angle of depression and angle of elevation. So the angle of depression, wherever you are, you're going to draw a line of eyesight first, and then a line down to where the object is. And it's the same with the angle of observation. You're always going to draw that horizontal line first and a line up to the object. And that is the angle of elevation. Okay, so let's do some examples of right triangle trig. Example 8 from our book. A surveyor is standing 115 feet from the base of the Washington Monument. The surveyor measures the angle of elevation. So here's the surveyor. He's making a line of sight first, and then the angle of elevation to the top of the monument. So then we're going to draw a line to what we want to see. And so we want to know that angle, there's the angle of elevation, which is 78.3 degrees. How tall is the Washington Monument? So if we would draw this situation, we have 115 right here. We have our right angle here. We have our angle of elevation at this point, and we want to know the height. So that is what we want to know. So we're going to keep in mind our SOHCAHTOA. And we're going to think to ourselves, what three things am I dealing with? What three things am I dealing with? I am dealing with this angle. I'm dealing with the side adjacent. And I'm dealing with the side opposite. So which trig function deals with adjacent and opposite? And it is tangent. So we're going to write this problem. Tangent 78.3 degrees is opposite over adjacent. So then we multiply both sides by 115. And then we're going to use our calculators. Now make sure your calculator is in degree mode. We want it to be in degree mode. So make sure it says degree. So 115 times the tangent 78.3. Hit enter. Y is approximately 555.31 feet. Now you try the next problem. So you should pause your video so you can watch the next, so you can do the next problem and then watch it back to see if you are correct. So the next problem, from the angle of elevation, so again, we have adjacent and we have opposite. So we're going to use tangent as our trig function. And some of you might be thinking, why is she not using cotangent? Well, cotangent is not a button on our calculator. So we want to only use the three trig functions that are buttons on our calculator. So you should get 40.01 feet. Example 9. Example 9 says a historic lighthouse is 200 yards from a bike path along the edge of a lake. So it's 200 yards. A walkway to the lighthouse is 400 yards long. So that is the diagonal. Find the acute angle theta. So here's our theta right in here. So now this time, here's my angle. This is the side opposite, and this is the hypotenuse. So opposite and hypotenuse is sine. So sine of some angle theta is 200 over 400. Well, that reduces to 1/2. And we should know from right triangle trig, the angle that the sine of theta is 1/2 is when theta is 30 degrees. So you should pause the video again. Try to do the student try. So find the acute angle between the two paths. So this time we are given adjacent and hypotenuse. So that is cosine. Adjacent is 3 and hypotenuse is 6. Now, what angle is cosine 1/2? And that is a 60-degree angle. Example 10. Find the length C of the skateboard ramp shown in the figure. Find the horizontal length of the ramp. So for this problem, we actually have two things we need to find. We need to find A and we need to find C. So let's look at the problem two different times. So we have 18.4, that's our angle, 4, and C. So from this angle, this is opposite and this is hypotenuse. So opposite and hypotenuse is sine. So sine 18.4 is 4 over C. Now this problem's a little bit different than the other ones. The other ones we had the number on the top and our variable was in, we had the number in the denominator and our variable was in the numerator. This time it's the other way around. So we first need to multiply by C to clear our denominator. And now we're going to divide by sine 18.4. So 4 divided by sine 18.4 is 12.67. So C is approximately 12.67 feet. Okay, now we need to find A. So I'm going to draw my triangle again. And I'm going to put the given that were in the problem, because this is just an approximate, it's not an exact. The 4 is the exact. And then we need to find the A, which is the adjacent side. So this is adjacent and that is opposite. So we have tangent. So tangent 18.4 is 4 over A. So A tan 18.4 equals 4. Now A is 4 over tan 18.4 degrees. So A is approximately 12.02 feet. Now you take a minute or two and try the student try. So I'm going to do two triangles again. This is an 11.5 degree angle. This is 3.5 feet. And I'm going to find C first. So we know sine 11.5 degrees is 3.5 over C. Now once I rearrange my problem, I have C is 3.5 over sine 11.5 degrees. I'm going to use my calculator and I get C is approximately 17.56 feet. So again, 11.5. The A is our adjacent. So tan 11.5 degrees is 3.5 over A. So we're going to rearrange it, and that gives us A is going to be 3.5 over tan 11.5. Then we use our calculator, and A is approximately 17.20 feet. Now, I would like you all to take some time and work on the next worksheet in our packet, and then I will have the video after this video for you to watch me do the problems.